Hello everyone, welcome back to my YouTube channel. Today we are going to see Maharashtra State Board Class 8 Science Chapter number 15 Sound. As we know about the sound is nothing but a form of energy. Till here we have already said about the various forms of energy like light energy, electrical energy, chemical energy, nuclear energy, tidal energy. So different kind of energy or the different forms of energy already we have studied. One of that forms is nothing but the sound energy. So we are not going to talk about the energy part of the sound in this particular chapter. We are just going to study the basic part or the terms or the properties of the sound related with the sound. In that, the first of all, when we talk about the production of sound, they have explained over here this production of a sound with the help of this tuning fork. This is called as a tuning fork, a structure which is very useful to study the concept of the transportation or the traveling of the sound from one place to the another place. In this particular instrument, which we call as the tuning fork, we have this U shape, and these two arms are called as the prongs of the tuning fork, and this portion is called as the stem of the tuning fork, which is used or which is very useful in holding the tuning fork. When we strike this tuning fork on the rubber pad, when we strike this on the rubber pad, suppose if I'm having a rubber pad and I'm striking this on this, then this prongs starts to vibrate. The prong starts to vibrate. This will just vibrate like this continuously. Same way this side also it will go on moving like this. Now if I want to show you with the picture over here, you can see how this is a normal condition, and the air which is present in a surrounding of that tuning fork, they will be evenly distributed. You can see all the lines they are equidistant from each other. Now, when the tuning fork is struck on the rubber pad, it will start to vibrate. So, two positions are there. One, it will go outside, and one when it will go inside. So, when it's going outside, it will push the air column. If I just want to clear this one, this will start to push this air column. And then what will happen? This air columns, they will come closer to each other, and when it will go inside, it will be relaxed, and this portion will get forward further, and it will reach here, this position, and this will go on continuously. Again what will happen? This will go outside, again it will produce columns which will be very close to each other. So this particular section indicates that how the sound is traveling, because here this vibration, this produces a disturbance in the air column, and the disturbance what it's produced in the air column is nothing but what? Producing a sound. You might have seen that even when we are taking a long stick, a thin stick, and when we move it quickly in the air, then that produces sound. Even your scale, if you are having a scale, just move it quickly, the long scale, just move it quickly in the air, you will hear the sound what it's producing. And that's just because whenever the air column is getting disturbed due to any motion or the vibration, then that produces a sound. So this is about the concept of the sound production. Now when we talk about the sound and its propagation, this propagation of a sound requires medium. You might have heard about the sun and it's producing a heat. How it's producing a heat? Because of the nuclear fusion is taking place. The nuclear fusion is taking place on the surface of the earth, and there is a continuous explosions are taking place on the surface of the sun, but we cannot hear that. The light we can observe, the brightness in the sun we can observe, but the sound of that explosions we cannot hear. Why? Because there is a vacuum in between the sun and the earth. So that is also one example by which we can say that the medium is necessary. Because of that vacuum, the sound cannot reach up to us. To explain that, they have done one experiment over here. What they have done, the one glass jar they have taken, glass jar which is completely air filled, and then with the help of the opening or the neck of that, the bell is inserted inside the jar, and at the bottom, if you will see, there is a one vacuum pump is connected to vacuum pump. Now this function of this vacuum pump is to suck out all the air present inside the gas jar. But this is not at the beginning. At the beginning, let the air be inside, switch on the switch for electric bell, and as the switch is on, electric bells start to ring. We can hear the sound of it. And then what we have to do, we have to start this vacuum pump. When this vacuum pump starts, the air start to flow out. That pump will suck out all the air present inside the bell jar. In this, as soon as it starts, the sound what we are hearing from the ring or the bell reduces gradually, and it reduces, and the time comes when we are not able to hear the sound of this bell. Why? Because as the air reduces inside that gas jar, there is no medium, there is no medium, and due to that we cannot hear the sound, because sound cannot travel without medium. So this experiment shows that the medium is necessary for the propagation of the sound. Further is, okay, before moving ahead, there is a one activity for you. Activity is activity 1. Draw this diagram. Draw in notebook. You have to draw this diagram in your notebook. This is your activity number 1. After finishing with this video, you can draw and then you can send back to me. Let's go ahead. Now the further what we have to study is the frequency of sound wave. Now as we know, the propagation of a sound is in the air. Then there is a portions in that waves, portions of a peak and the low peak. You can see over here the atmospheric, they have shown increased pressure, that is a compression. When pressure is exerted on the air column, they are coming close to each other and they are forming this compressions. It's called as a compression. And when they are relaxed, it's called as the rarefaction. So we have a complete set of, if you will observe it, we have a complete set of compression, rarefaction, compression, rarefaction, compression, rarefaction, compression, and again rarefaction. So it goes on continuously. We have alternate compression and the rarefactions. So this is nothing but what the frequency of the sound wave. This is a sound wave which is traveling in the air, produces continuously compressions and rarefactions. Now the cycle of this compression and rarefaction is called as the sound wave, and that changes the pressure in the air. Another thing is when we talk about this compressions and rarefaction, then set of one compression and rarefaction, the consecutive compression and rarefaction is called as the one wave. Means here if I want to talk about, then we have this one wave, wave, wave. Like this, we have the wave, or the number of waves are connecting together and forming the sound waves. Further is the next what we have to study is a sound and music. Now the sound and music, this two are very closely related. You cannot separate them. When we talk about the sound and music, they are interconnected. When we talk about this music, in that we have the seven notes, and that seven notes are given over here: sa, re, ga, ma, pa, dha, ni. This seven notes what we have, they all have this frequencies. They have a different frequencies actually. Frequencies means the number of waves traveling in 1 second. In a previous part to this, already we have studied about the waves, the rarefaction and the compressions coming together and forming the waves. So how many waves are traveling in a 1 second? That's called as a frequency. So here we have 256 for the sa, 280 for the re. Like that we have a different frequency for the different note of the music, which is called as the madhya saptak. So this is called as a saptak, and intermediate frequencies what we have, they are called as the madhya saptak. Further is when we talk about this music, music is incomplete without the or it's not complete without the musical instrument. So every musical instrument, they have a certain part in them which produces the sound. So let's see what their names are. Here they have given some of the pictures for the musical instrument. So let's see. This one is a sitar. These things you can note in your textbook. This one is a sitar. This one is a flute. And then we have a santoor. This is called as a santoor. I'm giving a common well-known names to you. Then we have a clarinet. This is called as a clarinet. Then this one is called as a mandolin. This one is called as the bugle. This one is called as the tabla. And this one is called as a saxophone. So these are the musical instruments they have given over here. You can note it down this in your textbook. Further is what we have to study. If you want, you can note it down all these things. Let's go ahead. The further what we have to study is a sound produced by humans. When we talk about the humans can speak. Humans can speak, and that speaking is nothing but what? The production of a sound. As already at the beginning of the chapter we have discussed that the vibration is a must for the production of a sound. And in humans also we have the voice box where the vibration is taking place, and that vibration produces a sound. The different vibration produced in the voice box or the vocal cords produces a different sound. A person can speak in a different ways. A different sound can be produced by the person is just because of by changing the pressure on the vocal cords. Now here they have shown this picture. Let's see in this picture what we have is a flap that closes air track during swallowing. You can see here there is a flap like structure because what we have two pipes. One is the esophagus, which is used which is also known as the food pipe. Whatever we are eating, that goes through the esophagus and goes into the stomach. And the other side we have the trachea, which carries the air in the lungs. And this both are present here at the junctions. Both are joint at the junction where we have the epiglottis, which covers the air pipe, that is a trachea, to avoid any food to enter into the lungs. Further is there is a trachea, and then the backside of it we are having the esophagus. Now this vocal cord what we have, this is a part of the human body which produces a various sound. Further as if we want to discuss about over here, you can see upper end of the windpipe, that is the two cords are stretched across the voice box or a larynx in such a way that it leaves a narrow slit between both of them. Means in a simple way, if I want to show to you, this way we have the two, and there is a narrow slit in between it. There is a narrow slit in between it. So by applying a pressure on this two, we can make a slit wide open or narrow open. So by changing that, the sound what it's producing can be changed or deferred. So this is about the humans, or the sound produced by humans. So this is your activity number 2. So here we are having your activity number 2. This is your activity 2. You have to draw this diagram. You have to draw this diagram in your notebook, which we call as the larynx in human. Further, the next part what we have is the sound generation by loudspeaker. Now in the loudspeakers what we have, there is also vibration. As already we studied that vibration is needed, even in the speakers also the production of a sound is possible because of vibration and some more techniques. Of course, there will be some more things behind it which produces the sound. So let's see what we have inside the speakers. We have in this the permanent magnet. You can see this is a permanent magnet. If I want to change it, the color of it, so it will be much clearer. So this is a permanent magnet we have, and in at the center of this we have the coil. So as the permanent magnet is switched on, when we apply the electric current to it, to the coil and the permanent magnet, then what happens? It produces the attraction for the screen, and this screen is attracted towards the coil, and due to the stretching nature and the change in this magnetic field, what happens? Because when we give the electronic signal to the speakers, the current passing through the coil changes, and that current changing in the coil produces a different magnetic field. So attraction of that magnets will change, and due to that what will happen, this film will, or the screen will start to vibrate, and when it's vibrate, it produces a disturbance in the air column. The air column present near to it get disturbed, and that produces a sound. So this is nothing but what the production of a sound into the speakers. A simple, short and easy way to understand it. So this is about the speakers and how they are producing a sound. So this is your activity number 3. Activity number 3. This diagram also you have to draw. So this diagram also you have to draw. So this is all about your chapter number 15, that is sound. Still, if you find any difficulty in this, then you can ask the questions in the comment section of this video. Okay, so this is all about your chapter number 15, sound. So 3 activities given to you under this particular chapter, which you have to complete and send back to me by 48 hours from the release of this video.